this is Thomas Barton, and I'm in A block geometry, and this is my extra credit problem. So the first step is to look where we can start. So the first place that we might be able to start is right here, this triangle, this isosceles triangle right here. The first measure that we can solve is measure A. Since this is an isosceles triangle, this measure would be 29 degrees because of the isosceles triangle theorem, which states that if these two segments are congruent, then these two angles will be congruent as well. So measure A equals 29 degrees. Alright, so the next measure that we can solve is measure C. So measure C would be 180 minus 29 times 2, which would be 121 degrees. This would be so because the whole triangle has a total sum of 180 degrees, and so if you subtract these two angle sums, you'd get 121 for the measure of C. Alright, so the next measure or angle that we can figure out is angle E. And angle E is a vertical angle from C, which means that it will have the same measure as angle C. So angle E will have a measure of 121 as well. Alright, so the next measure that we can solve is measure K. We can solve K by using the total sum of the triangle, which is 180, and subtracting the 121 and the 35 from the K. So if we do measure K equals 180 minus 121 plus 35, we'd get a total measure of 23. So K would be 23. Alright, so the next measure that we can solve would probably be angle F. We can solve angle F by using the property of the straight line, which says that a straight line is 180 degrees. So if this part of the straight line is 121, then we subtract 180 from the 121 to solve F. And that would be 58 degrees for that angle measure. So F, the measure of angle F would be 58 degrees because of the straight line property. So then the next measure that we can solve is angle D. And we can solve angle D because angle F is a vertical angle from angle D. So angle D would also be 58 degrees because of the vertical angle property. The next angle that we can figure out would be the next angle that we can solve is angle G. Angle G we can solve because we know the measures of all three sides of the triangle, similar to this one. So if we take 180 minus 58 right here, plus the 25, we would get a total of 97 for G. So this measure, the measure of angle G would be 97, because if you take the total sum of all the angles and subtract by these two parts, then you get that part. So now we can solve the measure of angle H. So the measure of angle H would use the straight line property. So 180 minus 97 plus 29 would make the measure of angle H 54 degrees. So this would be 54 degrees as the measure of angle H. So the next angle that we can solve is angle B. And we can solve angle B by using the same sum property of the triangles. So if we take 180 minus 54 plus 34, we can get the measure of angle B equals 92 degrees. Alright, so the next measure that we can solve would be the measure of angle I. And that would also use the straight line properties we've used before. So if we take 180 minus 29 plus 92, we can get the measure of angle I is 54 degrees. (54 degrees) is the measure of angle I. So now the last measure that we need to solve is angle J. And angle J we can solve by using the sum of the sum of the angles of the triangle. So if we do 180 minus 58 plus 54, we can figure out that the measure of J is 63 degrees. So using all these properties, such as the sum of the triangle and also the straight line property as well as the vertical angles theorem, we can figure out all the measures of these angles in this triangle. Thank you. Alright, so here's problem number 2. So, problem number 2, we can start out by putting in our givens. So we know that AD is congruent to DC. So AD is congruent to DC. And we also know that the measure of DAC is 59 degrees. And we know the measure of EBF is 7 degrees. We also know that this EFGD, this quadrilateral, is a rectangle. So if we know that it's a rectangle, we can put in that each of these corner sides are right angles, which is a property of the rectangle, and this side these two sides are congruent, and these two sides are congruent in a rectangle. And then we also know that quadrilateral ABGD, this is a parallelogram. So we know that if it's a parallelogram, that this side is parallel to this side, and this side is parallel to this side. So these are our given values that we know. So to start off, we can find the measure of angle 7. Angle 7 would have a measure of 90 degrees because of the property of the rectangle, which makes these corners 90 degrees. So measure 7 is 90 degrees. The next one that we can figure out, let me just put that in there. The next one that we can figure out is the measure of angle 11, which also has the same property as 7, and it's on the corner, which makes measure 11 90 degrees as well. The next one that we can figure out is measure 17. And we can figure out measure 17 by looking at this triangle and seeing that by our given that AD is congruent to the DC, that this triangle right here is an isosceles triangle. So if it's isosceles, that would mean that this side and this side would be congruent, which would make measure of angle 17 59 degrees. So measure of angle 17 would be 59 degrees. So if we know that, we can figure out this last part of the triangle, as we know the sum of the triangle is 180, and if we subtract the parts, then we can figure out this last part. So the measure of 19 would be 59 plus 59 minus, or 180 minus 59 plus 59, which would equal 62 as the measure of angle 19. And that would be by the triangle angle sum. And so the next angle that we can figure out is 20. We can figure out the measure of angle 20 by looking at this right angle right here and knowing that if we have this part, which is measure 19 of 62, we can just subtract 90 from 62 to find this part. So 90 minus 62 would make the measure of angle 20 28 degrees. So this would be 28 degrees. So next, we can figure out the measure of angle 3. And we can figure out angle 3 by the straight line property. And so we know that the straight line has to be 180. So if we take 180 minus 59, then we would get 121, which would be the measure of angle 3. So 121 plus 59 is 180, which equals the straight line. So knowing these two, we can figure out this last part of this triangle. So if we add 121 to 28, we'd find that if we add 121 to 28 and subtract 180, on the other hand, if we take 180 and subtract 121 and 28, we'd find the measure of angle 4. So the measure of angle 4 would be 180 minus 28 plus 121, and that would equal 31 degrees. So the measure of angle 4 would be 31 degrees. The next angle we can figure out is the measure of angle 18. And the measure of angle 18 would be, we can figure out this out by the property of the straight line, and this would be the same as this, as 59 as 180 minus 59 is 121, as we already figured out. So the measure of angle 18 is 121. So the measure of 18 equals 121 because of the straight line property. The next one that we figure out is this 14, because we already know that the straight line is 180. So if we take 180 and subtract the 121, we'd figure out the measure of 14, which is 59 degrees. So if we know that this is 59 degrees, we can take a look to see what else we can solve. We can go back up here to this triangle, and we can figure out the measure of angle 6, which is solved by the triangle sum of 180 minus 90 plus 70, which would make the measure of angle 6 20 degrees. So if we know these two parts in this right triangle, we can, in this right angle, we can figure out this last part. So if we do 90 to figure out the measure of angle 5, we can do 90 minus 31 plus 20, which would be 39 degrees for the measure of angle 5. That would be 39 degrees. So another angle that we can figure out is the measure of angle 1. The measure of angle 1 can be solved by taking a look at these parallel lines and seeing that since these two are parallel and this is a transversal, this 59 would have to make this 1 59 by the property of alternate interior angles. Since these are two alternate interior angles, the measure of angle 1 is 59 degrees. Seeing this property in place, we can figure out the measure of angle 16 by seeing that these two are also alternate interior angles. So 16 would also be 59 degrees. So the next angle that we can figure out is the measure of angle 2. So the measure of angle 2 can be figured out by taking this straight line and subtracting 180 minus this 59 to get 121. And so the measure of angle 2 would be 121. The next measure that we can figure out is the measure of angle 8. And the measure of angle 8 would be 30 because of these two parts being 121 and 39, and you subtract 180 minus 121 and 39 to get 30 for the measure of angle 8. The measure of angle 9 would be 180 minus 59 plus 59, which would make measure of angle 9 62 degrees. So the measure of angle 9 would be 62 degrees. The measure of angle 15 would be 62 degrees because if you take this 28 and this 90 and you do 180 minus 28 plus 90, you would get this measure being 62 degrees. So then the measure of angle 10 would be 28 degrees because of if you take these two parts right here, the 62 and the 90, and you go 180 minus 62 plus 90, you would get 28 for this measure. The measure of angle 12 would be 90 because if this angle is 90, this angle would also have to be 90. So this would be 90 degrees, this measure. So then to find 13, you would take the measure of 14 and the measure of 12, so 59 and 90, and you do 180 minus 59 plus 90 to get 31 as the measure of angle 13. And this is problem number 4. So to start off, we need to put in our givens. So our first given is that GD and GA are tangents. So GD and GA are tangents. So if they're tangents, that means they are also congruent. So that's GA and GD would be congruent. The next given that we're given is that the measure of angle BGC is 40 degrees. So we'd put that BGC is 40 degrees. Another given that we're given is that the measure of the arc of DC is 75 degrees. So we should put that into. We also know that the measure of arc ED is 55 degrees. So the measure of arc ED is 55 degrees. We know that the measure of arc AH is 20 degrees. And the measure of arc HF is 30 degrees. The measure of arc FE, right here, is 20 degrees. And we're also given that HK, this segment right here, is 1.4 centimeters. That FK, this segment right here is 1.5 centimeters. KB, which is right here, this segment is 7 centimeters. GE, this segment is 2.7 centimeters, and segment EC is 7.4 centimeters. So now that we've put in all of our given amounts, we can start by finding out what we need to find. So these are all the measures, arcs, and segments that we need to find. So the first one that we can figure out is we can figure out the measure of arc BC. And we can figure out the measure of arc BC by using the Alright, so now we can figure out these measures. These are what we need to figure out. So we can figure out the measure of arc BC by using the theorem of two secants intersect on the outside of the circle. And those two secants would be this one right here So alright, so now that we've put in all of our givens, we can find the measures of these arcs, angles, and segments. So the first one that we can figure out is the measure of BC. And we can figure out the measure of arc BC by using a theorem that we've recently learned. this is that the two secants, which would be BG and CG, intersect on the outside of the circle. So these secants intersect on the outside of the circle, which would let us to use this measure right here as well as this measure right here. So how we do it is we would take the measure of arc BC, which we do not know yet, minus the measure of arc FE right here, this smaller measure. We take the bigger measure and subtract the smaller measure over 2 equals this degree right here. And why we can do that is that's one of the theorems that we learned in class, which is the two secants intersecting on the outside of the circle, or the big arc minus the small arc over 2 equals the angle measure right here. So once we plug that in, we can find out that measure of arc BC minus 20 over 2 equals 40. So we can find out that the measure of arc BC would be 100 degrees. And once you multiply 2 over and then add 20, you would get that 100 degrees. So the measure of arc BC is 100 degrees. The next arc we can figure out is the measure of arc AB. And we can figure out the measure of arc B by using the total sum of the arcs of the circle. The total sum of the arcs of the circle is 360. And if we take the total sum of 360 minus all the rest of the parts, we would get the remaining part right here. So if we add up all these parts, 100, 75, 55, 20, 30, and 20, we would get 300 degrees for those parts. And if we take 360 minus 300, we get 60 degrees as this last part. So the measure of arc AB is 60 degrees. The next measure that we can figure out is the measure of angle EGD. And we can figure out the measure of angle EGD by seeing two secants intersecting on the outside of the circle, similar to how we did this one. So if we look at EGD right here, we can find that out by we can find this measure out, which we're looking for, by looking at this smaller part of the circle and this larger part of the circle. So we'd use the same theorem that we used up here. So we would take 75 minus 55 over 2 equals the measure of angle EGD. And once we take that, we'd subtract these two from each other, so that'd be 20 over 2, which is 10, equals the measure of angle EGD. So the measure of angle EGD would be 10 degrees because of that theorem. Alright, so the next theorem that we can figure out, the next measure that we can figure out is the measure of angle AGF. And we can figure out the measure of AGF by using the same theorem that we've already used, the two secants intersecting on the outside of the circle. And the two secants that we'd use for the measure of AGF is secants AG and secants BG. So what we do is we'd use this part of the circle right here. We'd use this smaller segment, which is 50 degrees, and we'd use this larger segment this larger part on the outside. So what we do is we do the same theorem, so it would be the larger part, 60, minus these two parts right here, which would be 50. So we would take 60 minus the smaller part of 50 over 2 equals the measure of AGF. So the measure of AGF would be 10 over 2, which would be 5 equals the measure of AGF. Alright, so in order to figure out the measure of angle BKC right here, we need to use a similar method that we used up here. Except it slightly differs because this is a intersection within the circle. So what we do is we need to take the larger part of the arc up here and we need to add it to 30, which is this smaller part, and then divide by 2, which equals this measure right there, the measure of BKC. So if we do that, we get 130 over 2 equals the measure of BKC. So once we do that, we figure out that the measure of BKC is 65 degrees. Once we know that, we can figure out the measure of this length of KC. And how we can figure this out is the theorem of two chords intersecting. This theorem states that if this chord intersects this chord, then these two chords will have the same measure. So in order to figure that out, in order to figure out the measure of KC, we can take 7 times 1.5 equals 1.4 times x. And x would be the unknown measure of KC. So once we multiply 7 times 1.5 right here, we can get 10.1 equals 1.4x. And once we do that, we can figure out that if we do 1.4x divided by, if we do 1.4x, and actually this is a 10.5, not a 10.1. If we do 10.5 over 1.4, we can figure out that x is 7.5 centimeters, and that is the length of KC. So this segment length, KC, is 7.5 because these chords intersect, and so if you multiply this 7 times this 1.5 and equal it to this 1.4 times the unknown length of x, you can figure out by using algebra this segment right here is 7.5. So the last thing that we need to figure out is the measure of segment GD, which is this tangent right here, and the measure of segment AG, this tangent right here. In order to figure out these two tangents, we need to use a theorem that we used that's called the secant and tangent intersecting theorem of the outside of the circle. So according to this theorem, we should take EC, which is 7.4 centimeters, and add it to GE, which is 2.7 centimeters. And we take that segment, which added together is segment CG, and we multiply this by the smaller part of the segment, which is EG, or 2.7. So it's 2.7 times 7.4 centimeters plus 2.7 centimeters. And that equation will equal the tangent GD squared. And so if we use this formula, we can find out that 7.4 plus 2.7 is 10.1 centimeters. And we multiply that by 2.7, which will give us 27.27 centimeters equals GD squared, which is this tangent. And so we square root this in order to get just this tangent alone. And by doing this, we get 5.2 centimeters equals GD, the segment GD. So by knowing that GD is 5.2 centimeters, we can figure out AG by knowing that since these are tangent, they are congruent. So AG will also be 5.2 centimeters. Thank you.